everybody again. So today we're going to be learning about lesson 8.5 about combining independent and mutually exclusive events. Let's start. If you flip a coin once, the probability of it showing a head is 0.5. If you flip the coin a second time, the probability of it showing a head is still 0.5, regardless of what happened on the first flip. Events like this, where the first outcome has no influence on the next outcome, are called independent events. Sometimes there can be more than one state in a problem, and you may be interested in what combinations of outcomes there are. If A and B are independent events, then the probability of that A happens and then B happens is the probability of A times the probability of B. Or the probability of A and B is the probability of A times the probability of B. There are situations where it is impossible for events A and B to happen at the same time. For example, if you throw a normal die and let A be the event that you get an even number and B be the event that you get an odd number, then A and B cannot happen together because no number is both even and odd at the same time. Under these circumstances, you say that A and B are mutually exclusive events, and the probability of A or B is the probability of A plus the probability of B. The following worked example demonstrates how these simple formulae can be used. Worked example 8. James and Sarah are both taking a music examination independently. The probability that James passes is 3/4, and the probability that Sarah passes is 5/6. What is the probability that both pass? Neither passes. At least one passes, and either James or Sarah passes, but not both. Use the formula for combined events in each case. Sarah's success or failure in the exam is independent of James' outcome and vice versa. So the probability that both pass is the probability that James passes and Sarah passes, which is 3/4 times 5/6, which is 5/8. The probability that neither passes is the probability that James fails and Sarah fails, which is 1 minus 3/4 times 1 minus 5/6, which is 1/24. The probability that at least one passes is 1 minus the probability that neither passes, which is 1 minus 1/24, which is 23/24. The probability that either Sarah or James passes is the probability that James passes and Sarah fails, or James fails and Sarah passes, which is 3/4 times 1/6 plus 1/4 times 5/6, which is 1/3. Work example 9. Simon and John are playing darts. The probability that Simon hits a bullseye is 0.1. The probability that John throws a bullseye is 0.2. Simon and John throw one dart each. Find the probability that both hit a bullseye. Simon hits a bullseye, but John does not. Exactly one bullseye is hit. Simon's success or failure at hitting the bullseye is independent of John's and vice versa. The probability that both throw a bullseye is 0.1 times 0.2, which is 0.02. The probability that Simon throws a bullseye but John does not is 0.1 times 1 minus 0.2, which is 0.08. The probability that exactly one bullseye is thrown is the probability that Simon throws a bullseye and John does not, or Simon does not throw a bullseye and John does, and which is 0.1 times 0.8 plus 0.9 times 0.2, which is 0.26. Exercise 8.3. Standard cubicle die is thrown twice. Calculate the probability that 2 6s are thrown, 2 even numbers are thrown, the same number is thrown twice, and the two numbers thrown are different. So the probability that 2 sixes are thrown is 1/36. The probability that 2 even numbers are thrown is a quarter. The probability that 2 even numbers are thrown is a quarter. The probability that the same number is thrown twice is a sixth. And the probability that the two numbers thrown are different is 5/6. Question 2. A bag contains 12 colored balls. 5 of the balls are red and the rest are blue. A ball is drawn at random from the bag. It is then replaced and a second ball is drawn. The color of each ball is recorded. List the possible outcomes of the experiment. So the possible outcomes of the experiment is red, 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 blue, blue, red, and blue, blue. Calculate the probability that the first ball is blue, the second ball is red, the first ball is blue, and the second ball is red. The two balls are the same color. The two balls are a different color. Neither ball is red. At least one ball is red. The probability that the first ball is blue is 7/12. The probability that the second ball is red is 5/12. The probability that the first ball is blue and the second ball is red is 35/144. The probability that the two balls are the same color is 49/144. The probability that neither ball is red. The probability that the two balls are the same color is 37/72. The probability that the two balls are a different color is 35/72. The probability that neither ball is red is 49/144. The probability that at least one ball is red is 95/144. Question 3. Devin and Tej are playing cards. Devin draws a card, replaces it, and then shuffles the pack. Tej then draws a card. Find the probability that both draw an ace. Both draw the king of hearts. Devin draws a spade and Tej draws a queen. Exactly one of the cards drawn is a heart. Both cards are red or both cards are black. The cards are different colors. So the probability that both draw an ace is 1 in 169. The probability that both draw the king of hearts is 1 in 2,704. That's a lot. The probability that Devin draws a spade and Tej draws a queen is 1 in 52. The probability that exactly one of the cards drawn is a heart is 3/8. The probability that both cards are red or both cards are black is a half. And the probability that the cards are different colors is a half. Question number 4. Kathy and Justin are both preparing to take a driving test. They each learn to drive separately, so the results of the tests are independent. The probability that Kirsty passes is 0.6, and the probability that Justin passes is 0.4. Calculate the probability that both pass the test, neither pass the test. Kirsty passes the test, but Justin doesn't pass. At least one of Kirsty and Justin passes, and exactly one of Kirsty and Justin passes. So the probability that both pass the test is 0.24. The probability that neither passes the test is 0.24. Again, probability that Kirsty passes the test but Justin doesn't pass is 0.36. The probability that at least one of Kirsty and Justin passes is 0.76. And the probability that exactly one of Kirsty and Justin passes is 0.52. Summary. Do you know the following? Probability measures how likely something is to happen. An outcome is a single result of an experiment. An event is a collection of favorable outcomes. Experimental probability can be calculated by dividing the number of favorable outcomes by the number of trials. Favorable outcomes are any outcomes that mean your event has happened. If outcomes are equally likely, then theoretical probability can be calculated by dividing the number of favorable outcomes by the number of possible outcomes. The probability of an event happening and the probability of that event not happening will always sum up to 1. If not A is an event, then A is the event that A does not, then A is the event that not A does not happen. And the probability of A equals 1 minus the probability of not A. Independent events do not affect one another. Mutually exclusive events cannot happen together. Are you able to find an experimental probability given the results of several trials? Find a theoretical probability. Find a probability that the event will not happen if you know the probability that it will happen. Draw a possibility diagram. Recognize independent and mutually exclusive events and do calculations involving combined probabilities. So that's the end of this video. Thank you and goodbye.